The fundamental theorem of algebra tells us that there's 4 potentially unique zeros, but no more than 4. Okay, but we got to find out which ones are real and which ones are imaginary. So we got to find those zeros and find out what they are. So what I would do for this is I'd try to break it down into linear factors using, to start, the rational zeros theorem. I want to take this and divide it by like an x minus 2 or an x plus 3 or something. So the rational zeros theorem says you partner up all the possible factors of the last number, so positive negative 1, positive negative 2, positive negative 4, and divide that by all the possible factors of the first number. So 1 or negative 1 could work. 2 or negative 2 could work. 4 or negative 4 could work. Okay, we don't know which ones will work. We have to just plug them in, but those are all the possible rational zeros. And if that's confusing, you want to pause and go check out the rational zeros theorem video. But that's all we do for the rational zeros theorem. It just gives us a list, and now we're going to plug in those numbers. So if I plug in 1 in for x, let me start with negative 1. If I plug in negative 1 in for x, let's see if it turns out to be a 0. This is 1. This is positive 2. This is 1. This is a positive 4. This is a positive 4. So that doesn't turn out to be a 0. Okay, I plugged in negative 1, didn't work. Let's plug in positive 1 though. If I plug in positive 1 in for x, I get 1 minus 2 plus 1 minus 4 plus 4. Minus 4 and plus 4 makes 0. The 1 minus 2 makes negative 1. Negative 1 plus 1 makes 0. So positive 1 works. So what that means is that this can be divided by x minus 1. I need a division symbol there, sorry. It can be divided by x minus 1. That's because 1 is a 0. If I plug in 1 in here for x, I'd get 0, right? And 0 would distribute and make everything else 0. So what we know for sure is that f of x can be rewritten as x minus 1, because again 1 is a 0, but we just don't know what all this other stuff is going to be over here. So that's where we can use synthetic division to break this down, or long division. Okay, long division is where you'd be doing x minus 1, dividing it into x to the 4th minus 2x to the 3rd plus x, you get it, right? I'm going to use synthetic division just because it's quicker. So if I put 1, and I'm going to put 1, negative 2, copying down all the coefficients. If you're not familiar with synthetic division, then you should be familiar with at least long division. So try it with long division, see if you get the same result. But there's also videos out there for synthetic division. But synthetic division works, you copy down those coefficients, okay, carry down the 1, and then multiply 1 times 1 to make 1. And then you add these columns. Negative 2 plus 1 makes negative 1. 1 times negative 1 makes negative 1. 1 plus negative 1 makes 0. 1 times 0 makes 0, and then add the columns. 1 times negative 4 makes negative 4. Look, no remainder. And that should always happen if we're using the rational zeros theorem. So this thing was x to the 4th. We divide by something with x to the 1st power, so now the leading term is an x squared. And then this is, x to the 3rd. I can't subtract. 4 minus 1 is 3. Sorry. And then all the powers just descend. This is now x squared term. This is plus 0x, and then minus 4. So what we just did was we divided on x minus 1 from the original thing, and we got x to the 3rd minus x squared minus 4. Okay, and what you want to do is keep going with the rational zeros theorem. But I think that was actually it. I graphed this before and I forgot. And I think that's the only. No, sorry, there's one more. I kind of cheated because I was making up this problem. 2 is also going to be a 0. You could plug 2 into the original equation, but now you factored it, 2 should also be a 0 just for this part. 2 to the 3rd is 8, minus 2 squared, that would make 4. 4 minus 4 makes 0. So 2 is a 0. We can factor this thing down a little bit further. We know that since 2 is a 0, that means x minus 2 should be a 0, and then we'll have some mumbo jumbo over here. So we're taking this and we're dividing it by x minus 2. So we use synthetic division again. The root of the divisor, the root goes up here, then you copy down the coefficients. We need a 0 for the x to the 1st term, Then we draw a line. You always start by carrying down that 1. 2 times 1 makes 2. Add the columns. 2 times 1 makes 2. Add the columns. 2 times 2 makes 4. Add the columns. Okay, so what we're left with is x squared plus x plus 2. So we found two real zeros, 1 and 2. The other zeros come from using the quadratic formula. Now we've broken it down to a quadratic. So -1 plus or minus the square root of 1 squared minus 4 times a times c all over 2a. Okay, so it's -1 plus or minus the square root of 1 minus 8 over 2. So it's -1 plus or minus the square root of 7i. And where I'm getting that from is if you're square rooting a -7, that's the same thing as square root of 7i, because the square root of -7, you can factor out a square root of -1 from it. And we have a definition for that. The square root of -1 is I, so that's where I got square root of 7i from. So those are the other two zeros. So our answer is that there are two real and two imaginary solutions.